Let's talk about 1.5, casting and ranges of variables. Do you remember predicting the output of integers n1 divided by n2? As a human, you know that 1 divided by 2 is not 0, but rather the more accurate answer is 0.5. Let's take a closer look to see what your machine is doing. In this example, we are working with two integer values. Your computer will execute this expression and return an integer value. The result of this expression is 0.5, but because your machine needs to return an integer, it will truncate or cut off the values after the decimal and return a whole number, in this case, 0. We can force our machine to return the values we expect through casting. Casting operators, integers, and doubles can be used to create a temporary value converted to a different data type. Let's see casting in action. I've initialized a variable of type integer called a, and it stores the value 8. I've initialized another variable of type integer called b, and it stores the value 9. When my computer executes and displays the result of the expression a divided by b, we see the return value 0 displayed. When I cast variable a as a double, my computer sees it as 8.0 and returns a double value of 0.88888 and so forth. We see the same result when I cast variable b as a double. My computer will see it as 9.0 and return a double value of 0.88888 and so forth. You can see that the cast was temporary as variable a returns integer 8. Once again, you can see that the cast was temporary as variable b returns integer 9. Casting a double value to an integer causes the digits to the right of the decimal point to be truncated. Let's take a look at this example. Two variables of type double have been initialized. Look closely at this expression and what is returned. X divided by y will return a double value. I am calling the integer casting operator on x, which returns the integer 8. Look closely at the following expressions and what they return, especially when the integer casting operators are used. What do you notice? Some programming code causes integer values to be automatically cast or widened to double values. This involves the conversion of a smaller data type, in this case an integer, to the larger type size, in this case a double. Take a look at this example. We've initialized variables of both integer and double types. When an integer and double are in the same expression, the returned value will automatically be of type double. Values of type double can be rounded to the nearest integer using the casting operator integer and x plus 0.5, or casting operator integer x minus 0.5 for negative numbers. Let's look at this example. We've initialized three variables of type double. If we want to round the value in variable x to the nearest integer, we add 0.5 to the value and then cast the result as an integer. 7.5 plus 0.5 equals 8.0. The integer casting operator will truncate the values after the decimal and will return 8. If we want to round the value in variable y to the nearest integer, we add 0.5 to the value and then cast the result as an integer. Notice in this case, 9.3 plus 0.5 equals 9.8. The integer casting operator will truncate the values after the decimal and will return 9. If we want to round the negative value in variable z to the nearest integer, we subtract 0.5 to the value and then cast the result as an integer. Notice what happens in this case. Negative 1.7 minus 0.5 equals negative 2.2. The integer casting operator will truncate the values after the decimal and will return negative 2. Integer values in Java are represented by values of type int, which are stored using a finite amount, 4 bytes of memory. Therefore, an integer value must be in the range from integer.minValue to integer.maxValue inclusive. If an expression would evaluate to an integer value outside of the allowed range, an integer overflow occurs. This could result in an incorrect value within the allowed range.